This is section 7.01 of the Unit 7 Notes, Intro to Math Models. Today I am, as in you are the student, reviewing and exploring symmetry so that I can identify reflection and rotational symmetry. I will know I have it when I can successfully identify symmetry of a figure. In the notes, I also have problems involving functions and proportions, so we will also be going over that as well. The specific TEKs we're looking at for today's lesson is 5A and 6A. Function. A function relates an input to an output. To evaluate a function, you find the output by evaluating the function's rule. So think of a function as a machine. That machine will produce a product depending on what type of inputs you have, and then that product is your output. So in the case of math here, that input is the x value. The function, which can be labeled as f of x, g of x, h of x, m of x, whatever. You could also sometimes see it as y equals. That function will then put that input into its rule, into its machine. It will go through the rules and compute something and churn out a product, churn out a result. That's what a function does. A function takes an input and puts it through its rules and will give you an output. An x, in this case, that you'll input that will give you out a y. Or an f of x, same thing. Function notation. So, y equals f of x. Y is saying that y is the exact same thing as f of x. Now, what is y? Y is your output. What is the f? That's the name of the function. You read f parentheses x as f of x, the function evaluated at x. X is the input, what you're putting into the function to get your output y. So again, just some things for you to know when talking about functions. F parentheses x is read as f of x, the function of x. Think the output of f for the input of x. For example, f parentheses 3 is read as f of 3, the function evaluated at 3. Think of the output of f for the input of 3. Here's an example. I'm going to cover some things and reveal them as we go. So the function of f is defined by f of x equals x minus 6. What is the value of f at 3? F of 3. So again, f of x is our rule. The rule states that it's x minus 6. That is the machine. That's what we use to give us a product, to give us an output. So now it asks us to use 3 instead of x. So we're going to input 3 for every x that we see. So every x that you see here, let me choose a different color, is now going to get replaced with 3. So again, we have the following. The input is 3 for the input variable of x. So now it'll read f of 3 equals 3 minus 6. And now we're going to simplify the right side because we no longer have any more variables. It's just numbers that we can simplify into one single number. So when you do so, 3 minus 6 will give you negative 3. And so the output is negative 3 when the input is 3. F of 3 equals negative 3 for this function right here. Another example. I'm going to hide this right side right here to show y'all. Let's say we have the function h of n equals 12 plus n squared. Again, this is our rule. This is what will help us produce an output. The input, in this case, is the n. So now let's say I want to figure out what h of 6 is. So now my input is 6. Every n that you see is 6. So now once that n gets replaced, just type it into the calculator or do the math on your own. 6 squared is 36, which is 6 times 6. And then 12 plus 36 is 48. So evaluating this at 6, h of 6 is equal to 48. Okay, so you try number 1. Want you all to do the same thing. The function is r of x equals x squared minus 2x plus 3. So now x will turn into 5. I want you to evaluate the function at 5. So fill out the boxes, get your final result. You can, if you're on ClassKick, you can move the box to see if you get the right answer. And try this on your own, please. Otherwise, I'm going to go ahead and move forward and show y'all how to do this. So again, x gets replaced with 5. So this is 5 squared, which is 25, minus 2 times 5, which is 10, and then plus 3. And I believe the answer should be 18. And then there we go. Again, this is just showing y'all on the calculator. 5 squared. 5 squared minus 2 parentheses 5 plus 3 will give us 18. And that's it for you try number 1. Proportions. A proportion is an equation in which each side is a ratio. In any proportion, the cross products are equal. In a proper proportion, the cross products should be equal. What do we mean by cross products? We mean the multiplication of numbers across the equal sign in a diagonal. A proportion, another way you can give a proportion is as a fraction. So to determine whether you have a proper proportion, when you do the cross product, those numbers should be equal. So 3 times 12 gives us 36. 9 times 4 should also give us 36. And so if they are equal, this is a proportion. Okay? Now, there's going to be missing variables or missing values in a proportion, and we're going to need to find out what they are. To solve a proportion, we're going to cross multiply, just like I showed y'all right here. Again, let me just cover some things up. There we go. So for this proportion, what is the solution to the equation? 5 over 72 equals 8 over x. Well, this is a proportion, and with a proportion, we can cross multiply. So there's different ways to show this, but ultimately, it's going to be 5 times x is equal to 8 times 72. So what is 5 times x? We don't know. We just simply put 5x right there. And then what is 8 times 72? 8 times 72 is 576. So now we have 576 is equal to 5x. We want to solve for x. We want to know what this missing value is. So to do that, we do the opposite of whatever is attached to it. In this case, we have 5 times x. So what's the opposite of multiplication? Division. So now divide both sides by 5, meaning the 576. You're going to divide that by 5. You're going to get 115.2. And then the 5s over here will cancel. And then you will get the following. Let me erase this real quick. 115.2 is equal to x. Now, if you want to check yourself, then right here at this cross product, 5 times 115.2 should equal 8 times 72. And they do. So we got the right answer. Here's another example. So again, we want to know what the m value is. Well, we notice that this is set up like a proportion. A fraction equals a fraction. Therefore, we're going to cross multiply. M times 20 and then 8 times 70. M times 20, you can't do that, so you're just going to write it as 20m. And then you're going to have 8 times 70, which when you plug it into the calculator is 560. So 20m is equal to 560. Last thing we need to do is solve the equation by dividing or doing the opposite of whatever is attached to the m value. And that opposite is division. So we're going to divide both sides by 20. 560 divided by 20 is 28. The 20s on the left side would cancel. And again, m is equal to 28. You try number 2. Here is your proportion. I gave you all the first hint, which is to cross multiply. So fill out the boxes to set up the equation properly. Show your work by simplifying the right side into a single number, and then solve for the c value by getting whatever is next to it and dividing it to the other side. If you need to see and check your work, you can move this box right here and see if you're doing everything correctly. So at this moment, go ahead and pause the video, try this on your own, fill it out, and get your final answer. Otherwise, I'm going to go ahead and show y'all how to do this. So cross multiply 3 times c. Can't do that, so this is just simply going to be 3c. And then the next thing we're going to do is 7.5 times 10. Or 10 times 7.5. Doesn't matter the order. It's still going to give you 75. So again, 10 times 7.5 is 75. 3 times c, nothing to do with that, so we just bring it down. And then the last step we got to do is to get the c by itself, divide both sides by 3. And then c will equal to 25. And just to show you all in the calculator, 75 divided by 3, 25. And then there is your final answer. Then you can check behind the box to see if we did this correctly, and we did. That's it for you try number 2. So let's move on to the next portion. Exploring reflectional or reflection symmetry. So I have a little bit of a explorative website for y'all to do. It's linked in the class kick notes, but I also have the website right here. If y'all want to type this in a separate tab to get to it, feel free to do so. This is what it'll take you to. It'll take you to a screen with a bunch of different figures that you can access through this slider. Triangles, squares, rectangles, and letters and other objects as well. So, move the red dot to simulate folding shape along various axes. When folding part sits perfectly on top, all edges matching, then the fold line is a line of symmetry. So there is a line right here that's going to mirror whatever's on the right side to the left. And then as you spin it around, it's going to keep mirroring that side that it's focused on. And then the left side is the original shape. The right side is the right part of the shape being folded to the left to check for reflectional symmetry or line of symmetry. So if you would like, click on that website here in ClassKick and explore a little bit to see which figures have lines of symmetry. That first one didn't, the second one does if you put the line straight up. Notice how the shape is overlapping each other. So that tells us that we have reflectional symmetry. Number 3, again, we got symmetry going vertically, horizontally right there, and then, well, not horizontally, in a diagonal, and so on and so forth. Okay, so if you would like to explore that, go ahead, and then right here, type your response for your definition of what a line of symmetry is. After going through that explorative website, and after thinking about it for a little bit, what is your definition of a line of symmetry? And I'll just leave y'all to that. So if you want, go ahead and pause the video, do that. Otherwise, we're moving on. So, symmetry is the line that divides a figure into two congruent mirror images or mirror image parts. So, for example, we have a picture of a butterfly, a heart, and a square, diamond, whatever you want to call it. Along certain fold lines, it is symmetrical, meaning one side looks exactly like the other. An easy way to think about symmetry is to hold your hands in prayer form, and then to unfold them out. That space between your pinkies, imagine a line going down in the middle of your pinkies. That line mirrors one side for the other. So that line right there is the line of symmetry, which makes the left side look like the right side. A figure can have 0, 1, or more than one lines of symmetry. For example, the letter S. There are no lines that you could put on it that will make it reflect back at it. Reflect a similar image. If we were to cut the line in half right there, if we fold it up, it would not give us the same image up top. However, with the H, if we fold the top half down, and if we fold the left half to the right, or the right to the left, we have very similar images. And so this has two lines of symmetry. Letter A has one line of symmetry going from left to right. Horizontally, doesn't work anywhere you put it. P, same thing. E, well, P doesn't have anything, period. And then E only has one horizontal line of symmetry, that where you can fold the top to the bottom and it looks like the exact same image. You try number 3. On ClassKick, I want y'all to use the tool up top, which I'm going to zoom in real quick. This tool, this line tool, I would like for y'all to use that to draw your lines of reflection for each of these. And then if you can, use the pen tool to show how many lines of symmetry you were able to create. So just write 3, 4, 5, 6, whatever, right next to it. Or if there's nothing, put 0. So go ahead and pause the video. Try that on your own. Otherwise, I'm going to continue on and show y'all how to do this. Okay, with the first image, the star, we have one vertical line of symmetry and then another horizontal line of symmetry. There's nothing in the diagonals. If we try the diagonal, it will not match because this corner right here, when you fold it, is much shorter and stubbier than this corner right here. So it does not have an exact shape that can be reflected diagonally. It's only got two. Okay, the Starbucks, Miss Starbucks Mermaid, whatever her name is, has only one line of symmetry. Now, if we ignore some of the slight discrepancies here, this does reflect onto itself. So the left side looks exactly like the right side, minus around the eyes. So this would have one. Technically, it's not reflective, but we'll pretend it is. For the block with the arrows, we got one going vertically where the left side looks like the right side, and then we have another one horizontally where the top side looks like the bottom. So again, for this one at the bottom left, we have two. For this sign, which I forgot what logo that is, has three, each on one on each of the diamonds, each of the corner of the diamonds. So, for instance, you got one right here on this diamond. You got another one that splits it down the middle. You got another one going from the bottom right and then through the middle. Three different parts of our lines of symmetry for that figure. And then for the last one, for the sideways house, we only have one. Okay, and then that's it for this U-try. You can check your answers right here to see how many each one had. And there we go. Okay, another symmetry we're going to look at is rotational symmetry. I have another thing for y'all to explore. So the link is there for y'all to type up if you're just watching the video. And then there's a link in the class kick notes if you have the notes available for you. So when we click on it, it's going to take us to this page where you have 12 different figures that you're going to test if they have rotational symmetry. Okay, so read through it, mess around to see if you can rotate it and make it have symmetry. For example, this first figure, you can rotate it to a certain point. Notice the message that it gives you when you make it match. It matches the original figure. If that ever happens, you have rotational symmetry. Figure 2, rotate it around. Notice how at no particular point does the image match the original that you can see faded in the background. Therefore, this does not have rotational symmetry. So if you would like, go ahead and explore all 12 figures. In your mind, keep track of what it is or what has rotational symmetry and what doesn't. And then move this box right here to check yourself and see if you were able to correctly identify those that had rotational symmetry. So if you would like, pause the video and do that. I'm going to go ahead and show y'all the answers, which it's these figures that had rotational symmetry. The flower, snowflake, football, the weight, dumbbell, the construction sign, the fidget spinner, the boat steering wheel, and the recycling symbol. So those are all the ones that had rotational symmetry. You can rotate the figure around its center less than one full turn, and the rotated figure looks exactly like the original. That's what's called rotational symmetry. If you end up going one full rotation to make it look like what it did originally, that is not rotational symmetry. Rotational symmetry has to occur before you make a full turn. Okay, so what I would like for y'all to do is, in Class Kick, rotate these images by clicking on them and then using the handle to rotate them. And then I want y'all to see if you can identify which ones have rotational symmetry and which ones don't. Again, if you have access to Class Kick, please do that right now. And then you can check your answers right here at the bottom of behind this box. Otherwise, I'm going to show y'all which ones have rotational symmetry and which ones don't. So the McDonald's symbol. Again, when I rotate this, at some point it's got to look like the original before I make a full rotation. So going around, at no point do I see the M look like an M again until I get back to its starting position. So M, or the McDonald's logo, no rotational symmetry. Pepsi logo. Besides the colors, yes, this does have rotational symmetry. The colors, or the spots, look like the image from the original, or these curves, just different colors. So Pepsi has rotational symmetry. Starbucks, no, does not have rotational symmetry. Adidas logo, no, you cannot get it to look like the original. This diamond logo, I forgot what it's associated with. Yes, so you can make it look like the original a couple other times before you get back to its starting point. This sign right here, yes, Aerosmith upside down is still Aerosmith. So this does have rotational symmetry. Okay, then here are your answers. No, 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 yes, yes, yes. That's it for you try number 4. Last one, you try number 5. For each letter, circle if it has reflectional or rotational symmetry. Don't forget that reflectional symmetry can be vertical and horizontal. Some letters don't have any symmetry at all. So if there is no symmetry, don't circle anything. If a letter has both, circle both answers. So I'll do a few with y'all so y'all can get the idea. Does A have reflectional symmetry? So if I were to draw a line down the middle, choose a different color. Yes, left side looks like the right side. And that's the only one that I really see. So it does have reflectional. Rotational. Can I turn the A around to make it look like an A still before I get it to a full circle? No. So I would not circle rotational. Sorry, trying to look for another letter that I can help y'all with. So the N, is it reflectional? Can I create a line that will reflect from one side to the other? And I believe not. There is no reflectional going on with it. But if I were to rotate that N before going one full rotation, can I get a symmetry going with the N when I rotate it? And then yes, you can. When you rotate it upside down, it's still going to look like an N. So therefore it has rotational value, or rotational symmetry. Okay? So again, I would like for y'all to go through all these letters, A through Z. Try them out on your own. And then I will reveal the answers in a few seconds. So go ahead, pause the video, try this on your own. Otherwise, I'm going to just show y'all the answers. So here are the answers for A through Z. You can read them yourself, pause the video, and see if you did everything correctly. And if you have any questions on this, just let me know. There were a lot of letters. I didn't want to explain every single one of them, so I'm just going to show you what the answers are. If you need help with understanding whether they're reflectional, rotational, or neither, let me know and I will help. So that's it for 7.01 notes. Let me know if y'all need anything. Otherwise, I will see y'all later. Take it easy, everybody.